Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is Munchie is modular. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of length n. We need to find the maximum value of AI modulus with aj plus ak. In this is we have to find I, j and k, these indices over all the possible triplets. Well, they range from 1 till n and they have to be pairwise distinct. So for the input format, we have t test cases, and for each test case, we have two lines. The first line contains the integer n, that is size of our array, and the second line will contain n spaced integers. These are a1, a2 till an. As for the output, on a single line, we have to output the maximum value of ai modulus with sum of ai plus aj. As for the constraints, number of test cases will go from 1 to 10 raised to 3. Value of n, that is length of our array, will go from 3 to 5000, and the array elements itself will go from 1 to 10 raised to 9. Let's see some sample input. So for the first sample input, we have an array of size 3, and the array contains the element 1, 2 and 3, and their index is also the same, 1, 2 and 3. So let's say we choose our index as something like this. We choose our I as 2, our j as 1 and our k as 3. So now if I perform ai modulus, the sum of aj plus ak, the elements will be 2 modulus 1 plus 3, that is 4, and 2 modulus 4 is equal to 2, because modulus will give us remainder of the division between these two numbers. So 2 is the answer here. As for the second sample input, we again have array of 3 numbers. We have 1, 3 and 3. And let's say if we choose the same configuration as before. Again, what we'll do is we will do 3 modulus with 1 plus 3. This is 3 modulus with 4. Again, the remainder is 3. And as you can see, that's the answer here. Let's see how we can approach the solution. So first of all, let's think if I'm doing something like this. X modulus y. What is the max value that I can get out of here? So what could be the scenarios? If our x is equal to y, the remainder is going to be 0. If our x is greater than y, the remainder will obviously be something less than x. If our x is less than y, then as we have seen in our sample inputs, our remainder is exactly going to be x. So out of these three, what is the maximum? It is obviously x. So if we go over in our array, what is the max value that we can get of this equation that we're trying to find? That is ai modulus aj plus ak. Whatever it is, the max can be some ai, right? So the max value that we can ever find is going to be nothing but the max element, the maximum element present in our array A. So let's see, we sort our array A in descending order. So we have the A0, we have the A1, A2 till AN, all of them in the descending order. So this is the largest element, this is the second largest, and so on. So this is the best value that we can hope for. So we will try this later. Let's go to the second best value. Can we do something about this? So we have the second best value, and if we want to get it, we need to find modulus and modulus it with some number that is greater than this. Well, aren't we in luck? We have a number that is greater than this. So for a1, we can modulus with a0 and any other number. Literally any other number that is not 0 or itself, because we need to be distinct. We can do the modulus and get our answer as a1. So the base answer, the lowest answer that we can get is nothing but a1. And as we have already seen, the max that we can get is a0, the maximum element. So now our actual answer will range from a1 to a0. Remember, a0 is the largest and a1 is the second largest. So our answer will range somewhere between the second largest and the largest element here. So since we have already confirmed that we can get the second largest, Let's see if we can go higher than this. And higher than this means we want to get the largest element. So we already have a0 with us and we want to modulus with some numbers aj and ak. Now if this sum aj and ak is greater than a0, our largest element, then it would be the best for us. We will get the largest element as our answer and that will be the maximum what we are trying to find. Now, even if we don't get, even if aj plus ak is somewhere less than a0, we doesn't mind. Whatever the value is, we are just trying to find the max. So what we will do is, we'll write two for loops, go over all the elements as j and k. We get to find this modulus with a0 and we simply do a maximum with what we already know, that is a1, the second largest. So with the second largest and the temporary solution that we get from going through all of this, we simply check whichever is the maximum and that will become our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and our array. Then we sort our array in descending order. Now we know that our initial answer is the second largest element. That is nothing but the second element of our array. Now once we have found this, we try to check whether we can get the largest element as our answer. So for that, we write a loop for j and k. We try to go over all the variations of aj and ak and we test the modulus with the largest element a0. Now whichever is the modulus, we check whether it is maximum from what we have set as our initial anchor, that is the second largest element. With this, at the end, whatever is our solution, we print it, and as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, our array, and sort it in the reverse order. Then we put our anchor answer as the second largest element, that is, the second element of our array. Now, once we have this, try to check, go over j and k to find the modulus with the largest element. Now, whatever the modulus value comes, across the values of j and k, we try to get the maximum between this and our initial set answer. And whatever is the maximum, we print it at the end. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.